All right. We're going to work on more of these limits of trigonometric functions that have vertical asymptotes, and the cotangent function certainly has vertical asymptotes. Now, let me show you here what I think you want to recall. As I talked about this morning, I'm going to go to my website, and I'm looking at, again, those trig notes. And I don't think I see that there, but okay. So let's take a look. Guess I have to find it and go all the way back to the trig resources, 241. Graphing trig functions, and we're going to look at graphing tangent and cotangent here. So earlier today we looked at the tangent interval of one cycle with its vertical asymptotes. This is for tangent. And we want to remember cotangent. Now, the interval of one cycle for cotangent starts at 0 and ends at pi over k. And your vertical asymptotes are at those endpoints. So from 0 to pi over k, let's take a look at that here. So your interval of one cycle goes from 0 to pi over k. And again, your vertical asymptotes will be at x is 0 and x is pi over k. Now, in this example here, because we're looking at any function that looks like a cotangent kx, k here will be 1. Okay, because you got 1x there. So that makes everything a lot easier. So if k is 1, what that means is our vertical asymptotes would be at 0 and pi. So in this case, x equals 0 and x equals pi. So what I suggest to people is this. Go back and remember your graphing skills for cotangent. And halfway between that 0 and pi, your vertical asymptotes, this is where x is 0, x is pi. Halfway between is pi over 2 now. So I also remind people that when you graph cotangent, the curve here in green, this one cycle is negative x cubed. You're looking at a memorization device to how to graph one of those cycles of cotangent, and it's negative x cubed in my mind. So this is all the information you need here to remember about cotangent. And that's the first cycle of cotangent right in here is what we're talking about. Now, cotangent is periodic, so you repeat that cycle. When you see the fact that they're asking you for a limit now as x goes to 0, now this is what I mentioned earlier today regarding these trig functions that have their vertical asymptotes, because you really have infinitely many of them. Here's another one, for example. And another one over here. And this will be negative pi, by the way. We'll put that over here. And this will be 2 pi. But what I want to remind people about is as you're going to 0 now from both directions, from the left of 0, that limit is negative infinity. This curve is going down. To the right of 0, that limit goes up forever. So what I remarked earlier today is that the limits at the vertical asymptotes, this is not looking at any particular direction, meaning left or right. This is irregardless of the direction. And what I mentioned earlier was all of those vertical asymptotes, you know, the limits at those particular asymptotes does not exist. They go to different directions. So the second I see that I have a limit at a vertical asymptote for the trig functions that have vertical asymptotes, I already know the limit does not exist. So there's minimal work in some ways. If I'm looking at a left-handed limit or a right-handed limit, then I have to find if it's negative infinity or positive infinity. So this is kind of an easy one in a way. I just have to remember how the graph of cotangent looks, which means go back to this information that you learned in trigonometry about graphing cotangent, and that's really how this works. So it isn't too bad if I know some of the details, right? Anyway, let's see how this will work. This is a little different. This is different because the k value here is pi. So we want to look for those vertical asymptotes again for this cotangent curve. The interval of one cycle is from 0 to pi over k. Vertical asymptote happens at x equals 0. That's 1. And then x equals pi over k. But your k value in this case is pi. So what I know, again, is that x equals, or the interval of one cycle is going to be 0 to 1 now. And that's just the interval of one cycle. The vertical asymptotes are going to happen at x is 0 and x is 1. So 0 to 1, here is 1 cycle of cotangent pi x. But then the other cycle is to the left over here, because there's infinitely many cycles. 1, 0, negative 1. This is where x goes or equals negative 1 again. X equals 0. X equals 1. So I think of my cotangent curve sketch again. Again, this is a negative x cubed kind of curve. And when I focus on the limit being x going to negative 1 again, I do know this is where you have another vertical asymptote. I know we said we have it at 0 and 1, but that's only one cycle. The cycle to the left of that, another cycle, the vertical asymptote is happening again right here. So again, notice again in the curve, you're going to two different directions. So that means my limit does not exist because they didn't ask for a direction here as they say, what's the limit as x goes to negative 1? They didn't ask for that. They didn't ask going to negative 1 from the right or the left. So again, it's a very simple thing to know is that where are your vertical asymptotes? And if the limit is at a vertical asymptote, the answer is going to be does not exist. That's pretty much the blue. This is the sine curve. We don't need that. We're just looking at this. And so on the other side, even though, let's try to see if we can move this over. There's another cycle to the left here. I can move those things out of the way. Well, now you have maybe a negative pi over 2. And this will go down. If you guys recall, negative pi to another intercept. But for cosecant of vertical asymptote, the point I'm going to make is the curve's going to go down like this. And we don't need the rest of that because the question is, what's the limit around 0? And so we know at 0 you have a vertical asymptote, and what that's going to mean is the limit, again, does not exist. It's a two-sided limit. You're going to the right, you're going to the left. It's a two-sided limit. So I think I did sketch this curve right here as well for you guys. I used Desmos to do it. And at 0, as you guys can see, we're going in two different directions. It's a nicer curve than my sketch, but you know, the author of the text expects you to know that detail about sketching these reciprocal functions, you know, secant, cosecant, and the tangent and cotangent. All of those functions have vertical asymptotes. So again, the limit as x goes to 0 at a vertical asymptote does not exist. All right. And, you know, just to kind of give you guys a note again, or by the way, just looking at this picture, say, what's the limit as x goes to 0 from the left of cosecant? Well, go to 0 from the left. What's going on with that curve? The y-coordinate is going to negative infinity. The limit as x goes to 0 from the right of cosecant. Let's go to 0 from the right now. These points here on the curve, you're going now to, the y-coordinate is going to the positive infinity. So there you go. Of course, they're not the same. This does not exist. So ladies and gentlemen, that's kind of, again, going through all the details. And let's remember cosecant, okay, they want the limit as x goes to pi from the right. So where is pi? Pi is over here. We still have the sketch now. You're going to pi from the right-hand side, so all of these coordinates, these x values are going to pi from the right. Your y value goes down to negative infinity over here. So I'm just looking again at my sketch. That answer is negative infinity. That's kind of, again, the point I want to make sure you guys are aware of. That they did toss in a right-handed approach at a vertical asymptote, and you think of the curve. It's also over here again. You guys know this is where pi is. I won't label it. I guess I will. Okay. And you say, well, what's the limit as x goes to pi from the left for the cosecant curve? Well, I'm going to use my curve that I sketched. X going to pi from the left direction means you're going this way. The y-coordinate is going to positive infinity. So that sketch that we did originally answered 3 questions, maybe even more. So this limit's going to be positive infinity now. Because it's a limit as x goes to pi now from the left. You guys see that little symbol? And again, I drew the same cosecant curve. What's the limit as x goes to pi for cosecant? Did we answer that one already? No, we did the 0 limit. Oh, okay. I see what I did. This limit right here. We're looking at this vertical asymptote. So we're actually looking at both vertical asymptotes here. Well, because, again, both left-handed limit and right-handed limit are both different. We could just say that that limit for number 16 simply does not exist. So I think the moral of the story is simply this. You do want to know what those, the graphs of those particular trig functions look like, the ones with vertical asymptotes. And again, when I teach the 241, we actually give those answers and work on those little details, because I do know people will be answering limit questions when they get to Calculus 1. Limits at vertical asymptotes. And just to give you a note, this is a different question. It's not even on the worksheet, but the limit as x goes to pi over 2 of cosecant, we could get away with just simply saying, well, that's the cosecant of pi over 2. It's functional evaluation, right? Because this is going to be equal to f of pi over 2. Now you might say why? Because the domain of cosecant is all real numbers except at the vertical asymptotes. So at pi over 2, your cosecant curve is nice and continuous. You just have to know what's the value of cosecant at pi over 2. Now, there's various ways to do this. One way is to know the graph of cosecant, that this location is when x is pi over 2 and y is 1. So again, graphing trig functions is extremely valuable in a Calculus 1 course. In fact, it's valuable for a lot of courses in math and science. The answer is 1. So just knowing that graph, the answer is 1. And so this is one way to give the answer. Another way, again, this is a note, is that you're going to use that unit circle we talked about earlier. This is kind of nice and easy in a sense, because you say, why? Well, on the unit circle, when you're looking at circular functions, pi over 2, we rotate, is really 90 degrees. And that terminal point on the unit circle is x is 0, y is 1. That's the terminal point. Cosecant, that circular function of an angle, let's make sure we write it nicer than that. Cosecant of an angle is 1 over the y-coordinate value. And since the y-coordinate value is 1, we replace this y value with 1. And 1 divided by 1 is going to be 1. So some of those fundamentals that you guys learned in trigonometry, like working with terminal points on your unit circle, and you can see my sheet and I'll show it to you, and even graphing skills that you learn in the trig course, are all designed to help you get answers to limit questions in Calculus 1, because they assume you know about those particular topics. Now let me go back and show you, I guess, the worksheet that I say to students you guys can use on your exams will have, where is that trig formula sheet here? I do keep a copy of that unit circle terminal point information. You do need to know your circular functions, though. And then you can actually deduce really a lot of information. So I did send you a link to that, and I hope you guys enjoy this video, and that is that. And so I'm going to send it to you as a sort of thing to, I guess, view before you go to bed. Thank you so much.